Okay, so here, it makes sense to increase the price, you make more money. What about here? No.
Decrease price.
So how do you know where you are? How do you know if you're going to make money? Or you could try a bunch of numbers, or we could use a handy-dandy concept called elasticity. All right, so the idea here is that sometimes an increase in price increases revenue, and sometimes it doesn't. And so how do we know when it happens? So that's where we have elasticity. Okay, so elasticity. Elasticity we're going to call E of P. And I gave you the formula where it came from. I mean, what the final formula is. Let me just tell you kind of what it's supposed to mean. This is the relative rate of change of demand. Rate of change of demand divided by the relative rate of change of price. So it's saying, if I move my demand a little bit, you know, I can get a ratio between the two, because I know if I move my demand a little bit, I know what the price will do, I get a ratio. And there's a minus sign on the front. Okay? All of this distills down to the formula that I gave you on the prep video, which is this one. So all you're doing is you're taking literally the variable p, that price, times whatever the derivative is, divided by the original function with a minus sign out front. But this is an important piece because it helps explain what these numbers mean. Okay, so you guys, we computed some already. So let's use an example and start computing and see how we understand what they mean. Okay, so here's one. Manufacturer of sunglasses currently sells one type for $21. We have sunglasses. This is number, I don't have what page, I got it from the textbook, I didn't write it down. All right, so sunglasses, current price, $21. Okay, price is P, demand is X. That's pretty much always, right? Little p is price. So little p price and X is demand. And I know they are related this way. X equals some function of price, so they are connected. The demand is connected to the price, and it's equal to this. 9,500 minus 250p. So the first thing we're going to do is actually compute this E of P. And then we're going to ask some questions that will be able to help us answer. Okay, so how do I go about finding E of P? Minus P F prime of P all over F of P. I've just repeated the formula. So do I have P? Yeah, that's a letter. Do I have F of P? Right there. Do I have F prime of P? Not yet. Can I find it? Yes, very easily. So let's find F prime of P over here. What is it? Yeah, everyone agree with that? Negative 250? Yep. And most of the time, most of these are pretty easy derivatives. We don't use very complicated functions here. All right, so let's put it all in. So minus P times negative 250 divided by the original, 9,500, minus 250p. Cleaning that up, I'm just going to multiply the negative signs. So I'm going to get 250p divided by 9,500 minus 250p. And typically, it's you can clean that up further. What is 9,500 divided by 250? Does anybody know? I mean, can anybody compute that?
38.
4, yes, 38. I think you're right. So 38. So really, I can write this as this. I just divided everything by 250. As long as I divide every single term, these do not cancel. Okay, you can't cancel, you can't cherry pick. You can't just pick the ones you want. You can take it out of all of them. So this is fairly common. You're going to get nice simple formulas like this when you get down to the end. All right, so here's a question. So let me define a few more things over here. So this is a table over here. And so I know this, that if E of P is between 0 and 1, we call that inelastic demand. So I'm going to write a table here. It's going to be 3 lines long. And if it's exactly equal to 1, that's called unit elasticity. And if it's greater than 1, what would you guess? Elastic. Inelastic, unit, elastic. So let's think about what this means. When it's unit, so this right here is a ratio of changes. So if this one changes by 10%, if I know what E is, I know how much this one changes, right? So I can actually rewrite, a lot of times I like to rewrite that. In fact, I'm going to do that. So maybe if you have room under the table, let's rewrite it this way. I'm going to take this and write it slightly differently. I'm going to say, if I know the rate of change of price, I'm just multiplying both sides by the denominator. Rate of change for price, try again, rate of change for demand, I know, sorry, is equal to negative E of P times rate of change of, I'm doing this right? So I've just taken that E of P, that first definition, and I've just multiplied both sides by the denominator, by the price. So now what does this mean? This means if I know that this changes by 10%, that's a multiplying factor. I know exactly how that's going to change. That's what it connects how the price changes to how the demand changes. Okay, so if I come over here and I say, well, what is E of the original, where am I price-wise? I'm at 21, so I put in 21. This is my current price point, $21. So if I put in 21, I'm going to get 21 over 38 minus 21. Can somebody compute that for me? I can't do that in my head.
I mean, does it really matter as long as you know it's,
Let's just, it will, actually.
you know it's negative?
Hang tight, let's get a number on this. 1.2? 1.224? 1.24. All right, so what does that tell me? 1.24. That tells me that I'm elastic.
Negative 24%.
Right, so if my price changes by 10%, then my demand is going to go down by 24%. That makes sense. You raise the price, demand goes down. So from here, I know that if the price goes up 10%, I just stick it, I've got a multiplying equation. 10% here times whatever that is, 1.24 in this case, with the negative, because I know that my demand's coming down. That tells me what percentage change I can actually expect. So this is going to tell me, in this case, that the demand will go down 12.4%. Does that make sense?
Yeah.
Okay. So, depending on where it is, I can figure out exactly how that works. Okay? So that's one question. The next question might be, now we need to look at, so we need to finish this table. So we've got elastic, we've got this, yes.
How did you get the 10%?
I just pulled that out of my head. I said if.
Oh, you said, okay.
Sorry. If the price goes up. Yeah, sorry. Sorry, I have a tendency. So a lot of times if I don't put an if, it just says this produces that.
Okay.
Yeah. So I pulled that out of my head. So now so this is about demand. Now we need to look about revenue, because this will tell us something about revenue as well. And again, this is not this is in the book. You don't need to memorize this table. Yes.
Right, so like, let's say you picked 100%, and you know the demand would drop 124%, which would mean that you would not have any demand whatsoever.
Yes, and I think what we're going to find is that this only works for small changes. It's kind of like projections. Projections only work a little ways out. So a lot of times in the book you're going to have things like goes up by 10%, goes down by 5%. It's just little changes because it's like using the derivative to predict or project it. You can't go out very far without it losing its meaning. All right, so here's revenue. So when it's elastic, then it's what we think. Then it's what we think. When the price goes up, the revenue goes down. That's what elastic means, right? They go in opposite directions. You pull the rubber band, it snaps back. So I think of them as being opposite. So here, if price goes up, then revenue goes down. That's what elastic means. Unit elasticity means nothing's happening. Revenue's not changing. Okay? Inelastic means they're going to go in the same direction. When the price goes up, the revenue goes up. Right? So price goes up, revenue goes up. Okay, so I can ask this question. I can say, if the current price is increased by 10%, what will happen to my revenue? I can't put a number on it, but I can say whether it goes up or down. So here I'm in the 1.24, so I'm in the elastic. So if the price goes up, revenue goes down. Price goes up, demand goes down, enough that that balance is shifted and the revenue goes down as well. I can't tell you by how much, I just know that it goes down. Okay. So this is, so when you're looking at working through these problems, the first thing you're going to need to do is compute the elasticity, and that's pretty easy. That works out usually to a very simple answer. And then you're going to be able to plug in a current price and get a number. And you're going to come back to the table in the book. This is the tables in the book. And you're going to say, which category am I in? Inelastic, unit, or elastic? Figure that out. And then that tells you some information. It says that if it's elastic, let me back up. This E is exactly this. You can plug in a price change, multiply by E. The negative means the demand is always going down when the price, they work in opposite directions, and you'll get your change in demand. And then, again, based on these categories, you'll know whether the revenue is going up or down. So really, this is a matter of kind of taking, I would keep the table in front of you while you're working through these problems so that you can just kind of see, and you're basically just picking what category it's in, and then that tells you what happens. So you're using this one and then this table.
Oh, so it's negative EFP times rate?
Times, yes. And that just comes out of how we define elasticity in the first place. So what it means is, if the price goes up, that means that the demand will go down. That's what the negative sign brings us. The price goes up, this whole thing is negative, demand goes down. How much does it go down? It depends exactly on what, this is like a multiplier that tells you how much of a change there is. So if you're in this case, right, this is inelastic, meaning not very much is happening. I can increase the price 10%, but if my E of P is, I don't know, 0.5, then that means if the price goes up 10%, the demand's going down 5%. It's just not a real big difference. But when I get out here, if I had E of P, if I happened to have a number that was, say, 5, then that means increase of price 10%, what happens to the demand? Goes down by 50%.
Yeah.
So that's huge. So here, not very much is happening, very small changes. Here, potentially very big changes. The last thing I want to show you, and then I don't envision this part normally taking so long. So let me just show you this last piece that kind of connects everything together. Again, it's in the book as well. Revenue, we often, revenue is X times P, and typically it ends up being an upside down parabola. That's kind of our simplest form. So over here, so this is revenue based on price. Here we have increasing revenue. What do we have up here? Maximum revenue, right? And then we have decreasing revenue. This right here is a breakpoint. Here we have inelastic, right? Because when the price goes up, the revenue goes up. That's right here. On the other side is where it's elastic. When the price goes up, the revenue goes down. So this is one way to remember how revenue connects to elasticity. Inelastic means that they're going in the same direction, the price and the revenue. Elastic is they're going in opposite directions. Yes.
So is that max point, is that the unit elasticity?
Yes, it is indeed unit elasticity. Yes.
Well then, I mean, given the graph that you're showing me, I'm having a hard time understanding how inelastic changes are usually less drastic than elastic changes.
Oh, because this is a picture of revenue, and this small bit is talking about demand. So I
Okay.
don't put a number on how the revenue changes. All I can say is price up, revenue up. That's all I can say. When I start talking about demand, that's when I can actually say, if I know this change here, I know this change here. So importantly, I can be very specific about demand. Here, I'm just saying up.
Okay.
Yeah. Okay. All right, so